Welcome to today's webinar. Welcome to the Geospatial Professional Web Network. And today's webinar is on the sea level rise calculator and will be presented today by Billy Brooks from the NOAA Coastal Service Center, Office for Coastal Management. Billy is a physical scientist and senior geospatial analyst at the NOAA Office for Coastal Management in Charleston, South Carolina. He has worked on a variety of hazards and climate-related data, as well as decisions support tools with a focus on coastal inundation. We have a number of upcoming GPM webinars that will be available, that are available already. Guiding Conservation and Resilience Actions Now and for a Long View on Friday, June 27th. Geospatial Trends and Observations from Higher Education on Monday, June 30th.
Norman, I'm sorry. The slides aren't sharing on our end.
Of course not. Okay. Share seems to have ended. Try this one more time. And I apologize to everyone. Go back to the beginning. Well, nearly the beginning. So again, welcome to the Geospatial Professional Network. Today's program is the Sea Level Rise Calculator. Today you will be learning about the calculator as well as going through how it is used, and then have a question and answer section following. Our presenter today is Billy Brooks. He is a physical scientist and senior geospatial analyst at the NOAA Office for Coastal Management in Charleston, South Carolina. He has been with NOAA for over 20 years and has worked on a variety of hazards and climate-related data, as well as decision support tools with a focus on coastal inundation. We have a number of upcoming GPM webinars: Guiding Conservation and Resilience Actions Now and for the Long View on June 27th. Geospatial Trends and Observations from Higher Education on June 30th. They can be found at thegpn.org page/webinars. We have multiple upcoming programs: an Advanced GIS Leadership Academy, November 3rd through 7th in New Orleans, and the GIS Leadership Academy, December 8th through 12th in Savannah, Georgia. We have GPN's new Learning Access. You can log in, procedures, helpful hints, and following links. These slides will be made available to members after this webinar to proceed to that learning annex. So mark your calendar for GIS Pro in the Rockies in Denver. And on that, get connected, stay connected, join GPN, and we move on to today's program.
All right, thanks, Norm. Hey, everybody. Let me get things shared. Pretty sure I'm sharing. Norm, can you confirm?
Yes, you are.
Awesome. All right, well, welcome, everybody. Thanks for attending, and thanks for the opportunity just to talk about the sea level calculator. This is a tool that was recently released earlier in the year, and I'm going to talk through. So I'm Billy Brooks. I'm with the NOAA Office for Coastal Management. And in addition, Doug Marcy and Megan Tremmel are on the line also and can help answer any questions you might have. And as we go along, if you do have questions, please enter those in the Q&A section. So there is a difference between chat and Q&A. and Doug and Megan will do their best to answer those questions in the Q&A section. All right, so all three of us are with the NOAA Office for Coastal Management. If you haven't heard of that before, we are up underneath the National Ocean Service within NOAA. So you have the weather side of the house, we're under the Ocean Service. So today I'm going to talk about the sea level calculator. I'm first just going to run through some overview slides, give you a little background and context for it, and then I'll get into a live demonstration of the tool. All right, so as we set out to develop the calculator, we had several goals, but two of the main ones were to provide useful and actionable information on how sea level and flood frequency are changing over time and on the ground. So looking both historically, what's going on currently, and then looking ahead into the future with what might happen. Also, as you may or may not know, NOAA has a lot of data that's out there, and a lot of water level data and information that oftentimes is in different locations. So we set out to integrate a lot of those data sets and across the different sources into one location, just to make it easier to access the data and to also provide additional context to the data. We co-developed this tool with the NOAA Center for Operational Oceanographic Products and Services, or COOPS. They are the operational and authoritative source for NOAA's coastal water level data. So you might be familiar with the tide stations around the country. That's part of the National Water Level Observation Network. And so COOPS operates and maintains those tide stations. They collect the data. They do all the QA, QC. They create derived products from the time series data. Also, the tidal datums for the country are established at these tide stations. So they're really the house of all this data. Our office, we have a lot of geospatial data that we create and develop, but we also do a lot of user engagement and tool development and hosting. And you might be familiar with the NOAA Digital Coast in that bottom right graphic. That's housed out of our office, and it's a big resource that we all work on. All right, so when we set out to develop the calculator, we took the NOAA service delivery approach. So oftentimes, you have scientists or geospatial people sitting around saying, "Oh, I have a great idea, let's build it," whether or not people need it. So we set out to develop and really define what we did based on user needs. And we call that service delivery. And if you look at the graphic on the right, you see that continuous engagement with users is really at the center of that wheel. So through every step in the process, we were engaging with users. We identified stakeholders. So we first conducted a coastal inundation needs assessment. We developed 6 use cases that were based on detailed kind of one-on-one interviews with 14 different stakeholders from around the country representing different regions, different roles and responsibilities. We held 2 design review workshops with those stakeholders just to make sure, like, okay, this is what we heard in the interviews. This is what we've seen across different needs assessments. Are we going in the right direction? Got the thumbs up, incorporated feedback, and then really continued engagement with them throughout development. So whether it was, like wireframing or data development, building the tool, what functionality should we have or not have, different explanations of data, they were involved in all of it, which really, has the effect of making it useful. So we know going into it that we're going to come out on the other side with something that will meet user needs. And a couple of those needs that we heard is that users wanted to be able to select or set thresholds. So these are thresholds representing water levels, where when those water levels are reached or exceeded, there are problems. Also, they wanted to be able to visualize multiple types of data. And not only just visualize it, but have guidance on how do I use it? What do I do with this visualization? What happened? All right. So as far as the audience for the calculator, we're showing kind of 3 tiers of users on this slide. Tier 1 kind of being your general public, homeowner, congressional staffer, journalist. Doesn't really require, an in-depth understanding of coastal water levels and the different issues you might encounter. Tier 2 are your chief resilience officers, floodplain administrators, land use planners, and then Tier 3 really we consider kind of your coastal engineers. The calculator was built for those Tier 2 and Tier 3 users, so there's a lot in it. It can get complicated. There are a lot of bells and whistles and things you can adjust and modify to where the general public really wouldn't necessarily understand what to do with all the possible customizations. And so a resource that is available for them is sealevel.globalchange.gov. It was a resource that we coordinated with. Both of these were developed at the same time. We made sure that we didn't overlap too much and really targeted different users. All right, so here's an example use case that we developed. This is just to give you a sense of kind of what went into defining really what we were going to do in this tool. And so this one's for a coastal planner. This is based off of, again, the needs assessments and the interviews that we conducted. And so you have the different roles across the top. So chief resilience officer, city manager, land use planner. So we were able to develop these statements. So as a chief resilience officer, I need to know how many times flooding has happened over some time frame and how much it is increasing so that I can show the data to city council members to justify funding. So we had these different statements, these different problems, you might say. From that, we developed both practical needs, so defining the different charts and graphs and the data that would be needed, but then also the technical needs, like what's the functionality that we would need to communicate that. So we then took all of this information across our 6 different use cases and developed a set of requirements that we were able to take to our developers and work with them to develop wireframes and really to develop a set of requirements for them to go build the tool and for us to be able to QA/QC what was being developed, and also to get all the data ready that goes into it. All right, and so with that, I'm going to switch over to the actual calculator. And again, if you want to go there, the URL is coast.noaa.gov/sea level calculator. It's not the sea level rise calculator because sea level isn't rising everywhere. It's actually falling in some places like Alaska. So it's the sea level calculator. This is the splash page. And as you can see, hopefully, it's obvious that you would search for a location. But before I do that, I'm just going to scroll down. The way we organize the data and information in the calculator is through what we call quick views. And we have 5 of them. So future sea levels, changes in flood frequency, extreme water levels, observed sea level trends, and seasonal variation. So you can think of these as kind of curated sets of data and information around these topics. We provide some gridded data. So I mentioned a lot of the data are at tide stations around the country. We do have gridded data, and we are looking to expand kind of the gridded data that we have. If you want to access the data used in the calculator, the link is there for that. And then also if you're looking for real-time data, which this tool is not real-time information, we do send you off to the NOAA Co-op's website for real-time data. Just a little bit of background on how we collaborated across different federal agencies, and then frequently asked questions down below. So a variety of questions. We try to anticipate what would be asked and included questions that we have been asked. All right, so I'm going to go back up to the top, and we're going to do Charleston today. Our office is actually located in Charleston. We're a national office. We don't have to sit or live in DC, which is nice. And apparently it's hotter in DC today than it is here. So there's that. All right, so Charleston, South Carolina. What you're presented with is a map of locations. And I'm first going to zoom out. You'll notice that you have these darker blue, larger icons to where we have all quick views available. And then we have locations where we have limited quick views available. The primary reason for that is data availability, which pretty much is based on the period of record for that location. So if we don't have enough data, we can't develop certain long-term trends or extreme water level statistics. We can only create a kind of a limited set of data with a smaller period of record. So for the Charleston gauge, it's been there a long time. We can develop the full suite of quick views. But I'm going to zoom out just to give you a sense of the amount of locations and data in the tool. This kind of white grid that you see represents the 1 degree by 1 degree gridded sea level scenarios that were released with the 2022 Interagency Sea Level Tech Report that came out a couple of years ago. So those are available. If you click in a grid cell, you'll get the future sea levels quick view with the scenarios for that 1 degree grid. But then you'll see these different icons that I mentioned, which represent both current and historical tide stations. All right, so I'm going to zoom back into Charleston. And as I click on Charleston, you can see that I get the period of record. So we heard that it was important to provide that information. So it's there, give you the number of quick views, and then if you need it, the station ID. So I'm going to click on that. And now we're presented with the available quick views for this station. So again, all 5. If you click on the question mark in the upper right of each of these cards, you'll get information on what you can do with this quick view. So just kind of a quick bulleted list of the different things you could do. And that's available for each quick view. And so also we have this video link. And this video link is kind of scattered throughout the tool, hopefully to make it easily accessible. I'm going to click on it. You're not really going to be able to hear anything, but I just want to show that for each quick view, I have a customized video that kind of takes you through what's in the quick view and what you can do with it. So let's skip ahead and just show how the graphs are explained. And then we get into showing how different processes work. So when you get a chance, check those out. All right, so I'm going to click on the future sea levels quick view. So as it loads, I'll first go through just the general layout, and then we'll get into what we're looking at in this quick view. So across the top, you have just kind of some very general, buttons for functionality. We could search for a new location if we wanted to. We could also click on the video and get that here within the quick view. And then you can also switch between both your computer setting, and for mine it's light mode, but we have light mode and dark mode. So if you wanted to take screen grabs, for example, and you wanted this light background, you could take a screen grab with this background of the chart and include that in a report or presentation. Generally, I stick with dark mode. Just because it's a little bit easier to see the data. Also, we send you off, you can create a link to this calculator, and it'll take everything that you have set and then email that as a setting that you can share with others. And when they load it in, it'll load up exactly how you were looking at it. Along the left-hand side, you'll see different ways to customize what you're looking at. The first is the vertical datum. So we provide vertical datum transformations and allow you to set which vertical datum the data are referenced to throughout all of the quick views. And we allow you to change the units, both standard and metric. Here you can set a water level threshold, and I'll show what that can do in just a minute. In this quick view, we allow you to enter your own vertical land motion rate. So if you have kind of better vertical land motion data for your area, you can enter that in and see how the sea level curves are adjusted going out to the future based on your customized rate. The rate that's in there by default is the rate from the 2022 Sea Level Rise Technical Report. Also, this decade option allows you to kind of focus in on a certain decade. So if you're planning, let's say for 2080, you would select 2080. And then also in this quick view, you can change the reference year. So by default, it's the year 2000, or you can select 1992. And if you're a coastal engineer and you work with vertical datums and datum transformations between tidal datums and orthometric datums, this probably makes sense to you. And 1992 represents the midpoint of the current official tidal epoch, which is how you would do these vertical datum conversions. All right, so we could go through, set all of that. As you'll see, each quick view has kind of a main chart. And as I hover over, you can see that they are interactive. And then we have additional charts or tiles down below that kind of give you more information on the topic that the quick view is about. And then on the right-hand side, we have a fully interactive map. So in this case, it's zoomed in Charleston because that's the location we selected. Then you kind of have your standard map controls over on the right. Okay, so in this quick view specifically, we're looking at future sea levels for Charleston. These data are from the 2022 technical report that's explained down below. If you wanted more information, you could click on this plus icon in the upper right that's available for each little tile. And you'll get additional information on what you're looking at. Plus technical resources. We're also working on providing the different API calls that were used to create this chart so that you could actually just copy and paste that API request into your own browser or into your own tool and get all the data that went into get all the data that was used to create this chart. So let's say my threshold, as I'm exploring, you know, we have the the 5 different scenarios. So high, intermediate, low, and low. These are from the tech report. I can toggle those on and off. We also provide the regional observation extrapolation. So the blue squiggly line from 1970 up to 2020 represents regional observations. So these data are also from the 2022 tech report and just kind of give you a sense of what's happening in the Southeast region. From 2020 going out to 2050, it's an extrapolation. So it has taken the observed data into account and is extrapolated out using a quadratic fit going out to 2050, just to give you a sense of what trajectory this area might be on. So what we can do is we can use that to kind of target and answer the question, okay, you give me 5 sea level scenarios, which one are we on? That's a question we often get. And so if we use regional data, you can see that for Charleston, we're somewhere in between the intermediate and intermediate high curve. So as a planner, if I was interested in, well, what curve should I use? Or if I just want to educate my local elected officials, this is how I could use the regional observation data and extrapolation to kind of show like, okay, here's kind of where we're trending right now. That may change in the future, but based on the historical data, that's kind of where we're going. Then if I wanted to see like, okay, well, what does that look like on the ground? So I can click on the map. It will set my water level threshold and will actually display the appropriate inundation layer on the map. And so this is where things start getting interesting and interactive, is that clicking on the chart actually changes the map. And so also clicking in the table changes the chart and changes the map. So everything is interactive. We call it double binding is what our developers called it, just to where, you know, no matter what you click on, everything is synced up and is interactive. So in this case, if my threshold was 4.5 feet, I could see that sometime in between 2080 and 2100, so probably around, you know, underneath the high scenario in 2080, but then somewhere in between 2090 and 2100, I'd hit 4.5 feet under intermediate high. Also down below, you can see, well, under each scenario, what are the different contributions that are going in to that number? And those change based on the decade you select. Also, for that threshold, for the year, or in this chart, we're displaying the year that 4.5 feet mean sea level is exceeded. So for average sea level, for the intermediate high scenario, it's somewhere around 2092. So that's when this threshold that represents when bad things happen, that will become average sea level in 2092. But it's actually going to become our average high tide in 2054. So happening every day. So that it kind of brings home the message of, the ocean is not flat, it is not static, and tides are going up and down. And those tides are going to ride on top of whatever the sea level rise is going to do for Charleston. All right, so that's kind of a long explanation for this quick view that others won't take as long, but it's a similar setup. So for this one, I'm going to go to changes in flood frequency. And here we're showing in the main chart the annual flood days. So this is the number of days per year that the current threshold was met or exceeded. In addition, we're showing the inundation extent of what is right now the National Ocean Service minor threshold. What does that look like on the ground? So again, everything's interactive. For the NOS thresholds, so we have both NOS or National Ocean Service thresholds and National Weather Service thresholds. There is a difference between the two, and we do explain what that is and provide more information on it. But for this one, I'm just going to stick with NOS minor. You can see how many times this inundation extent or approximate inundation extent was met or exceeded. And you can see that that trend is increasing. Also, we can look out, this is historical data, we can look into the future. And because we're interested in the intermediate high and intermediate scenarios, we can see going out into the future, how many days might we expect that kind of inundation. And you can see that it's expected to increase. And so we could say for the days value, if that occurs 100 times per year, it's just way too many. And so that threshold is going to be reached sometime around 2050. We'll start seeing, based on the intermediate high and the intermediate scenario, this level of inundation. You can also adjust and actually input a custom threshold. So if we wanted to look at 2 feet, let's say, we will go look at all the annual flood count data and actually report back that custom information. So again, everything's dynamic and interactive, and then there are just additional takes on the data and information down below. All right, the next one I'm going to talk through is extreme water levels. If you're familiar with, let's say, the 1% annual chance or the FEMA flood maps, you could consider that an extreme water level that has a certain probability of occurring or a certain % chance of occurring each year. This is similar information. We only go out to about the 50-year value. We wanted to be really sure not to overlap or confuse with FEMA's 1% annual chance numbers. So we only go up to about the 50-year value. So in this chart, we're showing the different return periods or extreme water levels. And in this one, we have 2 different data sources that you can look at for extreme water level data. There's information from the 2022 tech report, or there's information from co-ops, again, kind of the co-developer of this tool. So for this one, we're going to select co-ops. And you can see the 4 kind of return periods. You have your 99% chance or your annual exceedance probability level, the 50%, 10%, and the 2%. So that 2% is approximately the 50-year value if you want to describe it that way. Again, you can customize everything over on the left. Right now, everything is referenced to mean higher high water. And the threshold is set to the National Ocean Service minor threshold. The blue line that you see is the max water level across each year, really each month, for the period of record for the Charleston location. So around 1989, you can see Hurricane Hugo with that peak. But I'm not going to select Hugo. I'm going to select something a little more recent. So if I wanted to say, okay, here are my top 10 events above mean high water for Charleston. Let's look at Hurricane Irma, which occurred back in 2017 and was a little over 4 feet. As I click on Irma, the map changes to display around 4 feet above mean high water. Also, my threshold is then set on the chart. And so if we look at the chart, in 2025, Hurricane Irma's level is about a 2% annual exceedance probability. So there's a 2% chance of occurring each year in 2025. But on the first quick view, we saw that really we should be focusing in on intermediate to intermediate high. So in this case, let's say we're building a critical facility. We have a low risk tolerance, so we maybe want to build it a little bit higher. So I'm going to select intermediate high. And we can see that while Irma was around a 2% chance event in 2025, as we go out into the future, around 2070, Hurricane Irma's inundation extent is going to be a 99% chance annual exceedance probability. So that's occurring one time a year. This kind of inundation occurring once a year is a lot. That's a lot of impact. That's a lot of damage. So looking out to the future, we might want to design for a higher event and consider what sea level rise might do to the different annual exceedance probabilities going out. So that's just one way to use this quick view. Another way, which I like, is if you click on this icon on the map, it kind of switches the view from kind of a chart-focused view to this map-focused view. And again, the map is fully interactive. We could zoom in and out, but we still have the charts. We can scroll down. I can look at the top 10 events and then just start clicking on them and see like, wow, okay, this is potentially what Hugo's inundation extent looked like. And then we can look at the different events that the Charleston station has experienced. So just another way to use kind of one of the bells and whistles associated with this tool. All right, now I'm going to go to the observed sea level trends quick view. In this one, we're looking historically. So we're saying, well, what is the sea level trend right now? And if you know trend data, there are a couple ways you could look at it. The red line that we show on the chart is the linear trend. So that's just across the entire period of record. What is the linear trend with no acceleration? So sea levels in the past have a great influence over what's happening right now and how, what is the slope of this line. However, we also provide that regional trajectory that I mentioned in Quick View 1. And in this case, we provide both the 83rd and 17th percentile of that trajectory. So you can get a sense that, here's the long-term linear trend, but there's actually been some acceleration in Charleston area. This isn't the case for everywhere, but at least at the Charleston station it is. And so what the regional trajectory captures is that acceleration. And just gives you a sense of where sea level might be heading. Other information that's on this quick view are the numbers that go with these trends. So the long-term change observed in Charleston is 1.44 feet of change. That equates to about 0.14 inches a year. Another factor with sea level rise isn't just all the different things that contribute to increased water levels. It's also vertical land motion. So Charleston is actually sinking. And across that same time period, vertical land motion in the Charleston area has been about 0.68 feet. And we also provide the rate for that. So, vertical land motion accounts for 0.68 feet of this long-term sea level change. So vertical land motion is yet another important thing to consider in planning activities. Regionally, between 1993 and 2020, there's been about 0.5 foot of rise with 0.2 inches of year. So you can kind of see this rate increasing. If we look from 2020 to 2050, can actually see the rate continuing to increase and the amount increasing. And then we also provide information on, where does that sit within the context of the global trend? So the global trend is about 0.13 inches a year. So regionally in the Southeast, we're looking at, 1/5 of a foot, or not 1/5 of a foot, 0.2 inches a year. about half of a foot. And so we're experiencing a greater amount of relative or local sea level rise in the Charleston area. All right, so that is that quick view. And then the last one is seasonal variation. In this one, we look at how sea level varies throughout the year. So we provide information on the average seasonal cycle. So that's what you're looking at along the right-hand axis. And that is this red line, just showing that generally, in spring and in late summer, early fall, we see our highest water levels in the Charleston area. And then we look at flooding days per month, also just to kind of show how those equate and go along with the trend. And this is what you might expect. This is when we're getting a lot of tropical systems in the area. And then if you scroll down below, you get information on, months with the most high tide flooding days. So in this case, November, and we experience our highest mean sea level in October. And the way you might use this information is if you were going to do any kind of, let's say, stormwater system management or maintenance right along the shoreline, you could plan to do that when water levels are historically lower in the year. You probably wouldn't want to do them during hurricane season, which that just makes sense off the top of your head, but now you have some data to show. We should do that probably in late winter, early spring is when we typically have our lowest overall average water levels. We also show how the extreme water levels vary by month, which can be useful for planning activities. And then in this view, we reorder the top 10 events by month. So you can see how, some of those occur in January, but again, most of those are occurring in those late summer, early fall months. All right, so those are all 5 quick views. Again, there's a lot that you can customize in here. We're working on usability improvement. So in a lot of review comments that we've gotten back, it can get a little clunky sometimes if you're switching locations. So we're working on usability at the moment, along with some other improvements. All right, and I've got one last slide. Okay, so this isn't just one and done. We're continuing to work on this tool to develop new versions of it. And future versions will include gridded data. I mentioned that before, but there's an effort within NOAA, specifically the National Ocean Service, to develop gridded data along the coast based on a hindcast of 43 years worth of water level information. So 43 years worth of hourly water level information at an average 500-meter grid spacing along the entire coast. These data right now are available from Texas to Maine, so the Gulf and East Coast and Caribbean. The model is that this is based on, it's based on AdCirc modeling and doing hindcast runs. We're getting it set up to run in the Pacific, so we will have information in the Pacific also, including Alaska and the Pacific Islands. But the types of data that we'll be able to provide, in between the tide stations are high tide flood frequency projections, the extreme data, mean sea level trends and projections, and hopefully datums. So we really want you to be able to do datum transformations in between tide stations. We're also looking at improving the vertical land motion data. So there's a lot of vertical land motion gridded data on the horizon. And so we've developed the tool in a way to where we can incorporate that gridded VLM data. We also are considering adding additional quick views. We're probably not going to do that at the moment, but there are a lot of data sets out there, and we're working with different NOAA partners and offices, and then even those in other federal agencies to figure out how we can include data into this tool. All right, so with that, we can move over to Q&A. Let's see, I don't know, Doug, do we have anything in the Q&A that hasn't been answered yet?
Yeah, there's one question I was about to answer. Maybe you can just go ahead and take that one live. Alexander Thompson wants to know if this tool is meant to be a companion to or ultimately replace the sea level rise viewer?
That's a good question. The NOAA sea level rise viewer here, we'll just go to it. These are two complementary tools. If you notice, so here, let's go ahead and click on get started. The sea level rise viewer, we work on that one too. It's kind of the same crew of folks. It's a fairly simple tool in the sense that the main goal is really to just go in and slide the slider up. We do provide scenario information in the tool, but it's a little bit different view, and it's kind of limited in the customizations that you can make. So we consider the sea level rise viewer more for the general public, a little bit more map based. You don't get all of the different types of information and data that are provided. However, we take the approach of map once, use many times. So all of the mapping data and map services that you see in the sea level rise viewer, those are the ones that you see over here in the map. So if I were to set that, actually, let's say, back to Irma. This water level that you're seeing on the map in the calculator, it's the same data that you would see over here in the sea level rise viewer. Also with the sea level rise viewer, there's a little bit, it's a lot easier just to get to the download page. So all of the spatial data that goes along with the sea level rise viewer and also the calculator are available for download from our data download page. So we don't expect to replace the sea level rise viewer just because of different audiences, but they are complementary.
Yeah, okay, Billy, there's another one. I'll read out. I can help you on this one too if you need to. Matthew Reed, he wants to know, talking about the discussion of extreme water levels and hurricanes made him notice that there's a pretty wide gap between gauges in the Big Bend region of Florida. And are there any plans to pursue collecting data in that area?
Do you want that one, or do you want me to answer?
I think the simple answer is no. There's no plans. The gauges are where they are based on where you see changes in the tidal range. Pretty much a lot of the Gulf of Mexico has the same tide range, so it doesn't change that much. So new gauges are expensive. They can cost like $10,000 a year just for maintenance, and so. But that is a place where it probably has the highest surge potential in the whole country, and we have seen, especially the last couple of years, storms hitting that area. So it's very vulnerable. But what Billy's showing you here, there will be information from this Cora analysis that will give you water level, like historical water level data in that region. That's the whole point, is that it's bridging the gap in between gauges. So on a 500-meter grid, you'll be able to get water level frequencies for the last 43 years. So that should help. I don't know if you want to add anything else.
No, I'm just trying to show, this is that kind of gridded modeling effort I'm talking about. You can kind of see the point density along the coast. So it's just an example of, you can think of kind of each of these grid cells almost like a virtual tide station. It'll be based on modeling, so not based on true observations at a tide station, but it will or does attempt to fill in the area in between tide stations.
Okay, another one was from Joe. If a station only has one quick view available, will that change, or have all the quick views been developed with the existing data?
At this point, it's very likely not going to change. For some of those stations, some of the ones that just have a limited number of quick views, those were temporary tide stations that were put in. And those likely aren't going to be reactivated or repositioned, by co-ops. The kind of the larger, darker blue stations, those are the long-term gauges. And so that's where you're going to get the full suite of products. So having said that, and then referring back to the last question, that the gridded data really is kind of the way that NOAA is attempting to fill in the gaps and to provide, a larger suite of products. So as we continue work on that gridded data and developing derived products from it, we'll be able to include, that information in tools like this.
The only other one was someone, it's anonymous, said that there was somehow their screen is magnifying so they can only see a small part of the image, but I can't see that on my end. It looks good that what you're sharing is all fitting on there. So
Okay.
maybe setting that they have, I don't know. But
Yep.
That's it for now.
Doug, it looks like there's a question in the regular chat.
Okay. Yes. Gabriella wants to know, you mentioned earlier that sea level decline occurring in Alaska. Could you explain a little further in relation to how other states are experiencing sea level rise?
Yep. So in places like Alaska, because of plate tectonics and also because of basically the land rebounding from the last ice age, it's actually still going up. And so in those cases, the relative sea level is going down because the land is going up. There are a couple places on the West Coast where it's similar. So like in Oregon, there are a couple places, but it's basically where the land is still rebounding or it's rising due to plate tectonics. And so in that case, globally, the water level or sea level might be going up, but it's not. But relative to those locations, it's actually going down. And so that's kind of the difference between locations. And then you have places like Charleston or up in the Norfolk area that are actually sinking pretty quickly, and down in Mississippi River Delta. So the relative or local sea level rise is much greater there because of land subsidence. I see a question from Joe, just showing where to download the data. It's a little, well, here, we'll go back to the tool page. So from this, well, I just went too far. So if you click on the NOAA meatball in the upper left-hand side, you get a few options. So you can go back to home, you can go to a tool page or digital coast. If you go back to home and then scroll down, there's this access data section. We actually have gotten feedback that it's kind of hard to find this, so we're going to put it in a better place. But if you click on that, a PDF, what is a PDF right now? We're working on ways to better incorporate this throughout the tool. We give you links to all the different APIs where we're pulling in data. And then you also will get information on where we're all the sea level rise inundation data. So right here down in the sea level rise inundation section, data download is this coast.noaa.gov/SLR data. You can get to that from the sea level rise viewer if you happen to be in that by clicking the data download button in the upper right. And that will take you to this location. There we provide all of our digital elevation models. So those are at a consistent 3-meter resolution for the country, based on LiDAR data. We keep them updated. So as new elevation data become available for an area, we update our DMs and we remap everything. Or as new tidal datum modeling is available, we'll remap. And just for you to know, we also provide our DMs to the National Hurricane Center. So all of the storm surge modeling and mapping that comes out of the Hurricane Center is based on these DEMs. And so you can be confident just that it's kind of the latest and greatest LiDAR data for an area. And then all of the derived data, whether it's raster data, vector data, it's all available on this website.
think we're there's one question. I don't know. We don't know what's going to happen there, Bruce. That's all I can say. I think that's getting close to time, Danielle. How are we doing on time?
We have about 10 minutes left. So if there's a few more questions you can answer. Otherwise, if we've answered all the questions, you can finish a little bit early.
Okay. Well, let me ask. Can you read Bruce's question? I can address that, Bruce. So far our office for coastal management, we've lost about 25% of our federal staff due to mostly early retirements, but also some of the like probationary employees that were only here less than a year have been gone too. So about 25%. And we put this calculator out last November, December timeframe, where we actually are planning on doing enhancements to it this year, some new development and some enhancements based on user feedback. We have sustained funding, base funding that is helping to do that, which will help keep some of our developers, programmers and developers continuing to be able to work on this. So as of now, we're going to keep developing it, and the Sea Level Rise Viewer 2, keeping the data up to date. If there's ever any new LiDAR data, if there's a hurricane and it causes a lot of damage, then they go back and fly new LiDAR, for example, like after the Florida storms, after Irma and all that. So we would get that new data and update it. So.
Yeah, I don't see anything else, so we might be able to end a little early, give people some time back in their afternoon. All right, well, that's all we've got. Again, I'll put our contact information back up on the screen. Please feel free to reach out. Part of what we do is technical assistance, and oftentimes it's nice to interact with real people rather than just developing data, but we like that too. So get in touch if you have any questions, if you have any ideas, if you need more explanation of something, or want to know any of the links that we provided. So again, appreciate it. Thanks for having us.